be here celebrating the 10th anniversary of the Barcelona BGSE. Okay, so this is a paper, it's a joint work with Mario Forni, Luca, Sala, and Marco Lippi, and it's part of a, I would say, broader research project whose keywords could be economic fluctuations, empirical macro models, and the role of information of for us as econometration. We have a companion paper on fluctuations in stock prices, but this paper is especially about business cycle. And the starting point, it's a very, I think, intriguing theory of business cycle fluctuation, the so-called expectation-driven business cycle theory, which basically, I think the first contribution on this was 1927, the book by Arthur Pigou. And it's a very, the theory is very simple, okay? So agents receive news about future development of the economy. So suppose that future increase or reduction in TFP with an unchanged current TFP. Agents react to this, so they consume more, they invest more, and this basically brings GDP up and down and creates fluctuations. There's been a lot of contribution studying both from a theoretical and from an empirical point of view this type of theory. Here I just, let me just mention the American Economic Review paper by Baudry and Portier 2006, which basically provides evidence that this type of news shock actually are a very important driver of the business cycle. Now recently, a very important paper by Blanchard and co-author basically relaxes one of the assumptions that were common to the previous paper in this literature, which is basically the assumption of perfect shock observability. Okay, so they take a limited information model where the agents basically do not observe time t the shock that happens, but rather they receive a signal, a noisy signal, which is a shock plus some noise. And they basically have to decide on the basis of the information they have. Now, and this is very nice because it has a very nice implication. And the implication is that basically business cycle can be driven by both what the literature call news shocks. I think the terminology in this literature is not very appropriate, but I'm going to use exactly the same terminology used. And basically news are the expectation about changes that that actually materializes, okay? So change in TFP, but also can be driven by what people call noise, which is basically expectation about changes that actually never materialize, okay? So these are kind of mistakes that the agents make because the signal is somehow noisy. Agents react to the signal, so they might simply react to something which is just noise, unrelated to actual change in the future. So basically, the central empirical question is, and it is the question that we are after in this paper, is what is the importance of this factor, news and noise, in order to as a driver of business cycle fluctuations. And this question, it's very challenging. You will see it. It's just okay. So yeah, think about something like the cold fusion. No? At a point, we were thinking that we could have a nuclear fusion at very low temperature, but then someone found some error in the proof. So basically, there's a signal, but this signal has no effect in the future development of the economy. Okay, so it's just if you want, a mistake. But I will be more precise on this. I will have a question that describes what we mean and what they mean by noise. So you expect a future change that actually never happens. That's the thing. Now, I think so. This is very challenging because basically under Under this limited information setup, the technique, the empirical technique we know, basically vector autoregressive model, or the standard techniques fail in correctly estimating the shocks. And this was the point raised by Blanchard and co-authors. And the reason is that, okay, so there's the intuition is very simple, okay? So if the agents take decision in a framework where they cannot see the shock, now if we as econometricians are able to estimate this shock, then the agents could do the same, and this basically contradicts this main assumption, okay? Now this is something that has to do with a problem called non-fundamentalness. Actually, it's not the standard non-fundamentalness problem, Answer and Sargent, where the econometrician has less information than the agent. Here is a deeper problem because the agent themselves cannot observe what actually, with certainty, what is going on in the literature. So the question is then, should we dismiss the empirical model we know, vector autoregressive model, in order to estimate this type of the economic shock within this limited information framework? Basically, yes, according to Blanchard and co-authors, or Barsky and Sims, in this paper we say no, okay? Our answer is no, and what we do basically in this paper is two things. The first contribution is a methodological contribution, and which basically aims at identifying structural shocks in a framework where agents have limited information about these random events. And then we basically apply this methodology to the case of news versus noise. And what we find is that basically this news and noise together, what we call noisy news, explain a substantial part of economic fluctuations, and especially noise, these noise shocks seem to be important for shaping economic fluctuations, okay? Now let me start with a very simple, extremely simple model. It's not even a model, but just to give you the intuition of why this noise can create fluctuations up and downs in the economic activity. So assume that the economic fundamentals follows equation 1. A, suppose if you want, just call it TFP, okay? A is AT minus 1 plus this epsilon T minus 1, which is a news shock, okay? And there's a shock to TFP that has no effect at time T on TFP, will have only effect at time T plus 1. Epsilon is white noise, and the agents basically do the following. They open the newspaper and they get a signal S, which is the sum of this genuine true economic shock epsilon T plus a noise, which is this VT. Okay, so VT is also white noise and uncorrelated with epsilon T. And what is the information set of the agents? Well, basically the information set of the agent is composed by the current and past values of TFP, of the economic fundamental, and the sequence of signal that the agents have received up to time T. Now, take a very simple consumption function. This is just taken from Blanchard and co-authors. Consumption is something like, depends on the long-run level of the economic fundamental. You solve for this, and you will find that consumption is basically depends on the expected value of TFP tomorrow given the information set. Replacing AT plus 1 with its definition, what we find is that consumption is TFP today plus the expectation of the shock given the information set. Now, under full information, the expectation at time T would coincide with the shock. But here, IT, the information set, does not contain the shock. So what agents do basically is they do the best they can. So basically they take the linear projection of the shock onto the signal. So basically this expectation here will be simply gamma times ST, the signal, where gamma is the linear projection coefficient. Now replace everything in C, and you will find that C, the consumption, will react both to the true news shock epsilon T, but also will react to noise. the growth rate of consumption, which is equation 5, basically tells the following. So when there's a signal, the consumption reacts to the noise shock in the following way. Okay? Consumer increase consumption by gamma, and then in the following period, consumer look back, they learn that the shock was noise, so basically they undo what they have done. So consumption increases by gamma and then goes back to zero. Now that's just a very simple, extremely simple model that basically shows that under this imperfect information setup, this type of noise shock might generate fluctuations in economic variable. So now, very good. Now, now why vector autoregressive models fail in this setup? Now, one can write the solution of the model as a MA, which is a function of epsilon t and vt, these two shocks. L is the lag operator, and one can see that the determinant of this MA is 0. Of the MA matrix is 0 in 0, which basically means that this MA is non-invertible, which means basically that there's no vector autoregressive representation for these two variables. Okay. Now, and what happens if I wrongly estimate a vector autoregressive model, like many of us are doing under this setup? Well, it is easy to derive the world representation of the model, the fundamental representation of the model, which is a representation that we would estimate using a vector autoregressive model, which is basically the first equation. And what happens is that the estimated shock will not coincide with the true shocks, but will be a combination of the present and the past values of the structural shocks. So if one just use a vector autoregressive model in a standard way, what we would obtain is something that different from the shock, and in particular it will be a combination of the present and the past value of the structural shock. So what are the solution to this problem? First solution is just directly estimate the economic model. Okay, so using some method to just estimate directly the economic model. Now the problem with this is that typically the models imply some kind of heavy restrictions. So for instance, we need to decide what is the process for the shock, and many other I would say arbitrary assumption in the sense that there's no much guidance in specifying these restrictions. And actually, I think that one example that this restriction might be could be delicate is that, for instance, two papers, Barskian-Sims and Blanchard and co-authors, that use basically the same model to estimate the effect of news versus noise, they find completely opposite result. Blanchard find that this noise component explains 70% of the variance of consumption. Barskian-Sims find that no more than 7–8% of the variance of consumption, investment, and GDP is explained by this by the shock. So what do we do? Now I'm going to give you only the intuition. Probably I will skip most of the econometrics, and then I will go to the result. Now, if one takes, okay, so equation 6 basically relates the fundamental shock, what we estimate from the vector autoregressive model, to the structural shock. Okay, so this is the objective. The objective is the estimation of these two things. Now, this implies that the structural shocks, epsilon and v, equation 7, will be related to the fundamental shock by means of this equation here, which means what? This equation simply tells us that the structural shocks will be a combination not of the current residual, which is what is typically done in the vector autoregressive literature, but will be a function of the future of the residuals of the fundamental innovation. And what is the intuition behind this? The intuition is that as time goes by, then agents look back and understand what happened in the past. So if today we use information about the future, in a sense the future will contain information about what is happening today. So that means that we cannot use in real time, for instance, this machinery, but we can use it in order to at least distinguish between and assess the importance of these structural shocks. So there are a few generalizations that we make in order to estimate the model. So in 2 words, basically the estimation of this model goes in 2 steps. First step is just the estimation of the fundamental representation, basically the Wald and the Cholesky representation, and then one has to, which is basically this piece here, and then one has to find basically the relationship between the structural shocks and the reduced form or the fundamental innovation. Once we do this, then we have the impulse response function, and we can interpret the effect of these 2 types of disturbances. Okay, so let me go to the result. There's a bunch of results. Let's see how much time do I have. But so first of all, the empirical specification, we use a vector autoregressive model of order 4 with for 5 variables. We use, so how do we measure this A? Now here is the time typically the audience start getting nervous, because in the baseline case we use the potential GDP, but we use also TFP, and the results are quite similar, are not exactly identical, but at least qualitatively the results are very similar. And then there's another problem, which is the following. Now, the agents observe the signal, but we are not the agents, so how do we measure this signal? And to measure this signal, we use a variable which is taken from the Michigan survey of the consumer, which is basically the expectation, agent's expectation about the economy within the next 12 months. So the idea is that this variable contains what people think about the future events on the economy, and the idea is that this variable will contain implicitly the information provided by the signal to the agents. Then we add per capita real GDP, consumption, investment, and basically we estimate the model using this untold econometric procedure, and this is what we find. Okay, so let me go directly to the interesting picture, which is this picture here. Okay, so these are the impulse response function. The black line are the point estimate. The gray area are the confidence band. For so here real means this news shock, and noise means this noise component for GDP, consumption, and investment. Now, for the news shock, the results are similar to what is expected. Okay, so the effect is it's very small at the beginning, then goes up and basically reaches a new long-run level after 30-40 quarters. The response for GDP is similar to that of consumption and investment as well. Now, what about noise? What about the noise shock? Now, the results what basically point out is the following. So the agents basically here react to the signal because they are uncertain about what is actually the underlying cause of fluctuations. So they increase GDP, they increase consumption, they increase investment, GDP increases. But then at the point, what happens is that the agents realize that what was happening in the past was just noise, was nothing. It was not actually a true event about the economic fundamental. So what they basically do is they undo what they have done. Okay, so the investment goes back to zero, consumption goes back to zero, and as a consequence, GDP goes back to zero. Okay, so what we have is a shock that basically creates a positive co-movement between the 3 variables, which is basically what we expect from a shock, from a candidate of business cycle fluctuations. Okay? Now we do some historical decomposition. So here the black line is the annual GDP growth rate, or a bandpass filter version of GDP, which is this black line here, and the red line is basically the component of GDP given by noise. Okay, so you see that there is a lot of movement, especially after 2000. In 2000. Which means basically that noise seemed to be a relevant and important part for GDP fluctuations. And in terms of variance decomposition, okay, so here is basically the composition of the forecast error variance for on impact 1 year ahead, 2 years, 4 years, and 10 years ahead for this variable. These numbers are the percentage of variance of this variable attributable to news, to noise, and to news plus noise. And if you look at this red number, so these percentages are pretty high. This is 40% after 1 year, 62% after 2 years. I'm not too comfortable with this number because I have to say that under other specification and some robustness check, these numbers are slightly smaller, but still a shock that explains 30% of GDP fluctuations is an important shock. And you see that a lot of explanation comes from this noise component. Okay, so then we have made some robustness check. Again, for instance, we try to use TFP instead of potential output, using different measure of S instead of using the Michigan Saturday variable, using stock prices or other leading indicator, and the results seem pretty robust. Now let me just conclude by saying that we think that this can be a quite general procedure. Actually, we have been thinking of trying to apply this procedure, for instance, to the so-called anticipated monetary policy shock, or maybe government spending shock or announcement. And basically what we believe is that this class of models still is alive, even under this probably more realistic assumption that the agents have only an imperfect perception of the shock driving the economy.
Okay, thank you. So we'll open it up for questions.
Suggest about the importance of news or noise shock during the Great Recession?
Sorry?
Does your analysis suggest that news or noise shock played an important role during the Great Recession?
Okay, so here there's a bit of a problem because basically the shocks at the end of the sample are not very well estimated. So I think we have to be a bit careful about the interpretation of this, and actually that would be very, very interesting. But I think we don't have much to say because at the end of the sample, these shocks are not very well estimated. But yeah, so probably we have been checking this, and the results were probably. It seems that the noise had a very large role for this. But again, I'm not too confident in interpreting in terms of historical decomposition, the results which are at the end of the sample because of the procedure, the shocks are pretty badly estimated then.
Go back to that table for a minute, because that seems to be informative about how quickly or slowly people learn.
This table here?
Yes. So an impact shocks would have the same effect because the noise and news are indistinguishable. The same set of shock would have the same effect on impact, whether it's news or noise. But then
No, yeah. No, but then, yeah, okay, so, Okay, the fact that the two shocks have the same effect, that's not an implication. Okay, so they might have a different effects, and that will depend even in the theoretical model, and that will depend on the variance of the shock. So
No,
it's
the shocks may have different sizes on average.
and also
It seems like on impact, if no one can distinguish whether it's news or noise, if I can't distinguish whether it's news or noise, then I have to react the same to both.
here the shocks are standardized to have the same standard deviation, which is 1, which means that the impact, given that the size is the same, the impact might be different, because the variance of the shock here, at least in the empirical application here, is not identified. So it's the variance of the shock is not identified. Now
There's some size news shock and noise shock which on impact would have the same effect.
there could be a combination. There could be a combination of the sizes which exactly.
I'm just saying that what's the half-life? How quickly do they learn about?
Yeah. Okay. So this is something that actually we could tell exactly how fast they learn, but I don't know why, but we haven't checked this, and because that depends basically on the roots of this polynomial of the impulse response function. So in principle, one could say, now here basically the effect is back to 0 after 20 quarters. So according to if this actually depends on our interpretation is that within 20 quarters, basically the agents have undone in their optimal way all what was done, say, in this first part of the impulse response function. That is more or less but one could exactly check how fast the agent learn in this application.
I just have one question. The way you present it and even the language used is a little puzzling, because if I think most models, what happens is you think about, I have some probability that something will happen, so I think this will happen with 50-50, and it turns out it happened probably 0.2 or something like that, or whatever, even if I think 50-50 or 50%. What's the difference?
Actually, but that's okay. So
Here is like, I mean, I know that was not for sure, nothing is for sure. So.
okay, so here, I don't have an answer for using the empirical, the results of the empirical application, but I have an answer using this simple stylized model. Actually, so the largest effect of noise is obtained when the variance of news and the variance of noise are the same, because that is the situation where the agents are most confused. They don't know exactly if it is news or if it is noise, because the variance of these two shocks is the same. Now, when the variance of the shock is of the noise is very high, the agents know that basically what is happening is just noise, so they won't react. Even that the agents know the variances, the agents will not react to the shock because they basically assign a high probability of being noise. While on the other hand, if the variance of the noise is very small, basically what is happening is that there's no noise. Okay, so when the variance tends to 0, basically we are back to the standard full information case. So yes, there's a mapping between probability of event happening and the reaction of the agents to these two shocks. And in this case, because of agents know everything else, know the parameter, know everything, the situation where they are confused the most is precisely when the two shocks have on average the same size.
Another question, I don't quite understand the statement that the variances of the shocks are not identified here. Because if we agree that the response on impact of a one unit shock to news and to noise should be the same, because they're from points of view equivalent, then I think the variance of the forecast error on impact, the relative variances of the contribution to the forecast, the variance of the forecast error on impact should effectively correspond to the relative variance of the shock.
So you mean the, okay, so if I take the, yes and no, in a sense that yes, if that were exactly, I mean, I might imagine that there's a parameter on top of the variances multiplying the shock on impact.
But it's the same for both shocks.
But yeah.
Oh, I see. But the relative variances are identified.
Exactly.
The relative, that's right. It could be different. The parameter doesn't have to be one, but at least the relative variances of the two.
Exactly.
Okay, I think we should stop there.